Good evening, all of you. I hope all of you practiced the programs what we discussed in yesterday's class. The program is about single inheritance. Now we'll see other type of inheritance, that is multi-level inheritance. Multi-level inheritance. So before going to this program, let me explain the concept behind multi-level inheritance. So in multi-level inheritance, actually we are going to have different levels. So here we will derive a new class from an existing class. Okay. A new class what we derived in the previous level will become the parent and will derive the new class, other class, and this is repeated for different levels. So I'll explain this in the form of a diagram so that you can understand what is the concept of this multi-level inheritance. So now let's say we have a class. So we have three classes. Let's say we have three classes. So first, this is having class 1. So class 1 I have, and class 2 and class 3. So now class 2 is derived from class 1. Class 2 is derived from class 1, and the class 3 is derived from class 2. So if you observe here, I can call it as this is level 0 or level 1. You can give any name. I can shorten level 0. And this is, I can call it as level 1, and level 2. So here we are talking about only 3 levels, but maybe you can take more levels also. Okay. If you want, you can derive class 4. So class 4 will be derived from class 3. So if you observe here, class 1 is actually is the parent class, and class 2 is nothing but child class. So if you observe these two, if you see only these two levels, if you see only these two levels, okay. So in these two levels, the class 1 will becomes the parent. So class 1 is parent. Class 1 is parent, and the class 2 is child. Okay. So class 1 is parent and class 2 is child. And similarly, if you see the remaining 2 levels, okay. So if you see here these 2 levels, so these 2 levels. Now if you see these 2 levels, okay, in these 2 levels, what will happen? So class 2 is parent. Class 2 is parent, and class 3 is child. Okay, so that is what the explanation I written in the description. Okay, so this is an example for multi-level inheritance. Multi-level. So we are having multiple levels, not only 3 levels. If you want, you can take more than 3 levels also. Okay, so now we'll go to the programming example, how this can be implemented in Python. So now we'll go to the programming implementation. So here, what type of example I can take? I can take some student example where I'll take example. I'll take 3 classes. Student 1 is base class, or I can say parent class. Parent class. Student 2 is child derived from student 1, and student 3 is child derived from student 2. Okay, so student 1 is parent class, and student 2 is student 1 is parent class, student 2 is child class, and student 3 is one more child. So this is the same problem we need to implement in our IDLE environment. Yesterday also we seen some example with respect to student 1, student 2, like that. So now also we'll implement same. Multi-level inheritance. Okay, so now I am going to define a class student 1. So in student 1 class, I can take some data members, or I can take some methods also. So I want to, as I mentioned, for all these things, again, I'm telling you must have the knowledge of class. If you don't have class knowledge, then again it is very difficult. Okay, so in student 1, I'll define some function, define M1. M1 is nothing but method 1. And I can take the self parameter, self. So here I can write print. This is level 0. Level 0 method. This is level 0 method. Okay, now I can derive. So child class. Child class I can define. This is, I can call it as parent class. Parent class. Okay, in parent class, just I defined student 1. In child class, I can write class student 2. Student 2, just I'll define method. The method is nothing but define M2. So here also I'll have this self, and here I can print this is level 1 method. Level 1 method. So now this is second level, and next I'll define one more level. Level 3. So if you want, this is, I can call it as parent class. This is level 0. Level 0. And this is level 1. And here, this is level 2. So here, one more shade. One more shade. So now, I'll define one more class here. Class student 3. Student 3. In this, I can define a method. Define M3 self. I can write print. This is level 2 method. Level 2 method. Okay. So now this example we are implementing actually. Just you compare what we are doing practically. So this is what we are implementing. So here class 1 means student 1, class 2 means student 2, and the class 3 means student 3. So the student 1 I am calling it as level 0, student 2 I am calling it as level 1, and student 2 student 2, student 3 are nothing but level 1 and level 2. So now if you observe here, so far I didn't return any inheritance. But here, what is the concept? If you see here, there is an arrow between class 1 and class 2. So class 2 is derived from class 1. So I am supposed to write this one. So student 2 is derived from student 1. Student 1. So now the student 1 is a base class and student 2 is derived from the student 1. And what about the student 3? Student 3 is derived from student 2. So student 2. Student 2 is parent for student 3 and student 1 is the parent for the student 2. So and once these all are over, now I defined all the classes. So here I defined 3 levels, level 0, level 1, level 2, and I defined 3 classes. And once this is over, now I'll write the main. Okay, main is nothing but simply I can create the objects for each and every class. So now if you see here, already yesterday we discussed in single inheritance. The main purpose of inheritance is nothing but reusability. We don't need to rewrite or we don't need to write the same thing again and again. Just we'll write once and we'll try to use the same thing in different places. So here also I created a 3 classes and I want to access student 1 information, student 2 information, and student 3 information. I want to access these 3 classes, student 1, student 2, student 3. I want to access these 3 classes by using a single object. So how it is possible? I need to create an object for the last child class. So for student 3, so S equals to student 3. Student 3. So this is very important. Why? Because what is the meaning of this? I'll mention the meaning here. So creating object for the last child. Creating object for the last child. Last child is nothing but student 3 here. Student 3 is derived from student 2 and student 2 is derived from student 1. So this is nothing but the last child. So once we created the object for this student 3, then we can write s dot okay, I can access any object. Why? Because it is very similar to, if you want you can remember this in other way also. This is very similar to grandparent, parent, and child. So here I am having 3 levels. So first level I'll have this grandparent or grandfather, and father and child. So this is very simple to remember. Okay. So grandfather is a parent for the father. So father is derived from grandfather and child is derived from the father. Okay. So this is simple example for multi-level. Okay. Same thing we are doing now. We are doing same thing here also. So we are trying to access the information of all the levels using the last level. So what is the last level? Last level is here student 3. Then student 3 is derived from student 2 actually. And student 2 is derived from student 1. This last student 3 class. First I can access s dot m3. So actually m3 is nothing but it is a method in the same class. It's a method in the student 3 class. So then I can access this s dot m3 and s dot m2. M2 is nothing but actually it is a method in second class, that is student 2 class. And similarly, I can access s dot m1. This is the way how we are going to access. So how can I access? Yesterday I showed you some example how a program is going to be differentiated if you are going to use the concept of inheritance, and same thing how it is going to work if we don't use the concept of inheritance. Okay, yesterday I showed some error also. We'll get an error if you are not using inheritance, but you try to access the information from other class. But here we are trying to access the information from the grandparent class. So here what I'm doing here, this diagram what I'm doing, I created an object for the child class, and with this child class object, I'm trying to access the information from the father class and as well as from the grandfather class. So this is what we are trying to do. So this is possible in multi-level inheritance because father is derived from the grandfather and child is derived from the father. So I can access the father information using child, and as well as I can access the grandfather information also using a child. Okay, so that is what we are trying to do in this program. So that's why here I can access these three methods. M3 is a student 3 method, M2 is student 2 method, and M1 is student 1 method. Okay, so I'll save this program as multi-level inheritance. Multi-level.py. Okay, so I'll run this. Okay, so now if you see here, we are able to access the information from the three classes. This is level 2, and this is level 1, and this is level 0. So we can access all these three classes information using a single object. So that is the purpose of multi-level inheritance. So here I'll write down the explanation. So in multi-level inheritance, we can access information, the information of parent class using child class, and we can access the information of grandparent class also using child class. How can we access? Because okay, since grandparent grandparent is the parent class from parent class or you can say grandparent is the base class for the parent. So this is about this multi-level inheritance. So we can access the information with the help of a single object in the last level. So here we are talking about only 3 levels. But if you want, you can take multiple levels also. It doesn't matter whether it is okay having 3 levels or 4 levels or any levels you can have. So let me give one more example. Let me give one more example so that you can understand better. So let me write some program for doing some operations. Multi-level, multi-inheritance. Example 2. Okay. So here our objective is we need to take some class A. So in class A, I need to consider some data. I can write some function here. So M1 define M1 and self define M1 self. So here I can write directly. I can take some return uh, print print this is class 1 method 1. Similarly, I can take class B and here I can write M2. This is class 2. Class 2 method 1. Class 2 method. This is class 1 method. This is class 2 method. And similarly, I can write class C. So class C, M3. So this is class 3 method. Next. Class. So here I can write M4. So M4 is nothing but so class 4 method. Class 4 method. So now I defined these 4 classes. Now I'll write the main program for this main program. In main program, what I'll do is I will create object for the last class, that is small d is equals to capital D. So this is object and d dot m4, d dot m3, d dot m2, d dot m1. Okay. So just here I took one more level, additional level. I took one more additional level, and with this additional level, we are going to add something. Okay. And okay. So I'll save this. multi-level 2.py. So here I took one more additional level, the object as no attribute M3. So here, why we are getting error? The reason why we are getting error is I didn't use the concept of inheritance. If you see this program, this is a normal program. All are independent. Okay, I didn't use inheritance. So that is the reason why yesterday also I explained you the reason why we are going to get an error. If you see here, A, B, C, D, 4 classes I created, but all 4 classes are independent of each other. A is not depending on B is not depending on C is not depending on D. So if you want to remove that error, then I need to use this inheritance. So A I need to derive, this B is derived from A, and C I need to derive from B, and D I need to derive from C. So now if you see here, B is derived from A and C is derived from B, and D is derived from C. Okay, so that is the reason why we got an error last time. So now if we see here, we are not getting any error, and we are able to access all the methods, not only methods, all the information of all classes using last level object. So here we can access the class 2, class 3, class 4, all the information using this last level object. Okay, so this is about multi-level. So not only this example, if you are going to practice different types of examples, then only you can understand the concept of multi-level. So maybe you can perform some arithmetical operations. Okay, so how you are going to perform mathematical operations using your multi-level inheritance? For example, you can take some addition operation. You can perform some addition operation in first level. Okay, next you can use some other subtraction operation, next level, and you can use multiplication. You can use division. So you can take some addition in first level. That addition you try to use in the second level. Next, the result whatever you got in the previous level, that result you need to access in the next level. So like that we need to access. So here if you are going to access any data, so that data you can use it from the previous level. We don't need to redefine again. We don't need to again accessing by declaring. Simply you can declare once and you try to access multiple times. So you practice some examples on numbers. So that is a simple practice for multi-level. So let me give some idea so that you can practice how this multi-level is going to work. So maybe you can practice this example. Practice. Okay, you can take some numbers. You can take some numbers in class A, means in first class. You can take some numbers. You can assign some numbers. A value 10, B value 20, like that. Okay. You can do some operation in class 1. You can add that two numbers in class 1. Whatever the addition you got in class 1, you try to access that addition value in class 2. Okay. By using that addition, you can add. For example, let's say I'll have some class 1, class A. So in this, I have something like A equals to 20 and B equals to 30. Some of these values in class A. Okay. In class B, what I'll do, class B, I can derive B from A and directly I can access A and B. I can write C is equals to A plus B. Okay. So how can I access A and B values in class B? Because B is derived from A, and whatever the information I have in class A, I can directly access it. So without redefining A and B values in a class B, directly I can access A and B. Okay, that is the main concept of inheritance. We are not redefining A value 20, B value 30 in again in class B. Directly I can access A, B in class B. And now in class C, means in third class, or in third level, what I'll do, I can write this. Okay, so here I can write D is equals to C into some okay 20. So here, if you see third class C, class C is derived from class B. Okay, in class C, what I am doing? I am doing some multiplication. For what? For C. But what about C? Is C is available in class C? C is not available in class C, but class C is derived from class B. But in class B, already I know C value. Directly I can access C value in class C. Okay. So here in this level, I have A and B. And this capital B class is derived from capital A class. That's why I am not redefining this A and B values. Directly I am accessing here. If you don't use inheritance, if you define class B independently, then you will get an error. Okay. So what about this class C? Class C is again, it is derived from class B. So capital C, class capital C is derived from capital B. So what I am doing in this class, I'm trying to find a D value. What is D? D is nothing but C into 20. And how about C? How I came this C value? Actually, C is not available in this class. Even though it is not available, I'm getting this C value from the above class. Okay. So from this class B, I'm getting the small c value, and the small c value, I'm using it here. Okay. So indirectly, what I'm doing is we are trying to eliminate all this redefinition, okay, operations. We are not redefining all the operations whatever we did in normal programming language. If I want to access, for example, in C language, there is no concept of inheritance. What I'll do, if I want to access AB values from one program to other program, or one function to other function, I need to redefine. Again, I need to define. In function 1, I can write AB. In function 2 also I can write AB. Okay, in function 3 also I can write AB. But what about here? Here we are not redefining. Just we are defining once, and we are trying to access those values in different classes. So that is the main objective of the inheritance. That is what we can call it as reusability. Okay, so like that, there are no limitation on the number of levels. We seen two example programs. In one program, I used 3 levels, and in other program, I used 4 levels. So like that, you can use any number of levels. That is dependent. For example, I'll tell you one more application. For example, you want to find the result of a student. Okay. So I'll give one more example. You can practice this one also. Practice. So here Our objective is find the result of a student. Find the result. So how can we find the result of a student? I can create one class here. In class, okay, in class student1, I can declare all subjects. S1 means subject 1. S2 means subject 2. S3 subject 3. S4 subject 4. S5 subject 5. I'll declare all subject marks. Subject 1, subject 2, subject 2, 3, 4, 5. In second class, class student 2, I'll derive this class student 2 from student 1. Okay. So in this directly I can find total. Total is equals to, simply I can write S1 plus S2 plus S3 plus S4 plus S5. Okay. So I can sum this all these subjects to get the total. Now in class student 3, as I got the total in my previous class, and student 3 I derive from student 2, what I'll do is simply I can find the average. Average is equals to, simply I can write total by 5. This is next level. In the next level, okay, so means in class student 4, it is derived from student 3. What I'll do here is just I'll compare if average greater than 45, I can write print pass. Else I can write print fail. So this is also you can implement. You can implement this using multi-level inheritance. I given two practice programs. Everyone please practice. Okay. So one is finding out the result of a student using multi-level inheritance. Second one is performing some arithmetical operations using multi-level inheritance. So these two are practice these type of examples, then you can understand how this multi-level inheritance is going to work. Okay, so I'll stop here. If you have any queries, please let me know.